Hi guys, welcome to my YouTube channel. In this video lecture, I am going to continue solving the next 10 questions from Magnetism and Compass chapter in RK Bali Navigation Book. So far I have solved 50 questions. I hope you have watched those lectures. You have understood all the questions, how to answer them. Let's continue this progress with a new question today, question 51. Concerning direct reading magnetic compass. So it's a direct reading magnetic compass. Okay, in the northern hemisphere, your position is in the north hemisphere, it can be said what? On an easterly heading, a longitudinal acceleration causes an apparent turn, a false turn towards the south pole or to the south heading. On a westerly heading, a longitudinal acceleration causes an apparent turn to the south. Easterly heading, a longitudinal acceleration causes an apparent turn to the north. So very important question. It's related to acceleration deceleration errors to which your magnetic compass is subjected. So we have this North Pole, South Pole, East and West. So let's take aircraft which is flying in easterly direction. Okay, which is flying in easterly direction. Now there are two possibilities. It can either accelerate flying easterly, it can decelerate when flying easterly. So when this aircraft accelerates on an easterly heading, there will be an apparent turn towards the pole which is nearest to it. Now this aircraft is in the northern hemisphere, so the nearest pole is the north pole. Whenever it decelerates, it will show an apparent turn. The magnetic compass will show an apparent turn towards the south pole. Okay, towards that pole which is far away from that aircraft. If you are in the northern hemisphere, so the pole that is far away from you will be the south pole, right? So even though you are flying 090 heading, the heading shown to you on the compass or shown to you by the compass will be any heading which will be towards or which will be tending towards 180, 120, 130, 150, depends on your rate of deceleration. Okay, similarly it depends on the rate of your acceleration, how much uh, how much heading will be shown to you by your compass when your actual heading is 090. Okay, so deceleration, a turn towards the south pole. Now take another aircraft which is flying in a westerly direction. Okay, it's flying in a westerly direction. So in this case, again, we have two possibilities. This aircraft accelerates. Whenever acceleration happens, again, the magnetic compass, instead of showing the right accurate direction 270, it will point towards a direction which is near to the North Pole. Any direction, 320, 330, 350, right? So an apparent turn towards the North Pole, since you are in the North Hemisphere. If this aircraft decelerates, it will show an apparent turn towards the South Pole. Okay, so instead of showing a 270 direction, it will show any direction which is less than 270, 250, 220, right? 190, 180, whatever. So this is the acceleration deceleration error. So now you are in the north hemisphere on an easterly heading, acceleration causes an apparent turn towards the north pole. Charlie is the right answer. Alpha is wrong because it says you are flying easterly. You accelerate your aircraft, nevertheless, the heading or the turn is towards the south pole. That's wrong. If you want an apparent turn towards the south pole, under these circumstances, you should decelerate. Instead of acceleration, you must perform a deceleration. On a westerly heading, acceleration causes an apparent turn towards the south. No, it will cause an apparent turn towards the north pole. If you want an apparent turn towards the south pole, slow down your aircraft, decelerate your aircraft. Next, at a specific location, the value of magnetic variation varies slowly over time, depends on magnetic heading, depends on true heading. So wrong. So correct answer is option alpha. Magnetic variation keeps changing with time, but that change is very slow and gradual. Next, in northern hemisphere, so you are in the north hemisphere, accelerating your aircraft easterly direction, right? The magnetic compass will indicate. So just how I explained, you're in the north hemisphere, your aircraft is pointing easterly. Whenever you accelerate, you get an apparent turn towards the north pole. So the right answer here will be uh, a heading of east. That is wrong. A decrease in heading, an apparent turn to the south. So answer will be Bravo. So now you're flying at a heading of 090 degree. You accelerate your aircraft. You accelerate your aircraft. So what will be the outcome? The outcome will be you will get an apparent turn towards the north pole. So what is the north heading? It is 000, right? So instead of getting shown an accurate direction of 090, you will be shown any direction which is less than 090, 050, 040, something like that, right? So a decrease in heading. The purpose of compass check swing is to do what? Cancel out horizontal component of the Earth magnetic field, cancel out the effects of magnetism on board of your aircraft, measure the angle between magnetic north and compass north. So your magnetic compass requires horizontal component. It requires horizontal component of the Earth magnetic field. Okay, it requires that. The horizontal component of the Earth magnetic field is the direct, direct, directive force. Okay, so this is what is useful to us. There are two components, horizontal component and vertical component. Vertical component is undesirable. Okay, it's not of use. Horizontal component is what is the directive force, right? So magnetic compass requires that. So this will be wrong. We cannot cancel it. Cancel out the effects of magnetic field on board your aircraft. No. Measure the angle between magnetic north and compass north. Yeah. So measure the angle between magnetic north and compass north. What is the angle between compass north and magnetic north? It is deviation. Compass deviation is the connecting link between what? Magnetic direction and compass direction, right? Now compass swing is performed to decrease this deviation value, the difference between the magnetic heading and compass heading. As okay, so compass swinging is done to decrease the difference between them as much as possible. Fine. So the correct answer is to measure the angle, meaning deviation between magnetic north and compass north. The magnitude means value, measurement of variation has a maximum value of 90 degree, has a maximum value of 180 degree, has a maximum value of 45 degree east or 45 west. So it's a theoretical question. It's given in the Oxford textbook as well that the maximum or the magnitude of variation will have a maximum value of 180. Remember this? Magnetic equator. Variation is 0, deviation is 0, dip is 0. Now variation is the angle between true north and magnetic north. Deviation is the angle between magnetic north and compass north. Dip is the angle between the horizontal component of the magnetic field and vertical component of the earth magnetic field. Okay, so at magnetic equator, the horizontal component will be maximum. Let's say this is your earth. This is the north pole. This is the south pole. This is the east and west. And this is where your magnetic latitude is situated like this. So at magnetic latitude, you will experience only and only the horizontal component of the earth magnetic field. Okay, horizontal component of the earth magnetic field. The vertical component of the earth magnetic field will be 0. Vertical component will be 0. Remember this. That's why the dip. Now, what is dip? Dip is an angle between horizontal component and vertical component. Now, if there is no vertical component at magnetic equator, that means there will be no angle formed. No angle formed means angle will be 0 degree. That's why we say dip is 0. Now, when you go to magnetic latitude, that is north pole or 90-degree latitude, 90-degree north or 90-degree south, over there the dip angle will be equal to 90 degree, because at magnetic north latitude or south latitude, the vertical component will be maximum, the horizontal component will be minimum. It will be reverse of this, opposite of this. At equator we have maximum horizontal component, at poles we will have maximum vertical component, right? So when we reach poles, the dip angle will be 90 degree. The dip angle will be 90 degree. So the angle formed between the vertical component and the horizontal component, 90 degree. So that is also important question. The ergonic line. Now what is ergonic line? We have two lines. Isogonal lines. Lines joining places of equal magnetic variation. Okay. Equal magnetic variation of values more than 0 degree. Okay. And ergonic line is that line which joins places of only and only 0 degree variation. So places that have variation value of 0 will be connected with a line called ergonic line. So follows geographical equator, not necessary. Joins places of nil variation, yes. Is midway between north and south poles, wrong. Disadvantage of remote sensing compass, okay, over direct reading compass is what? Turning errors are increased. Detector unit is exposed to high deviation errors, susceptible to electrical failure. Yes. So remote sensing compass runs on electricity. So if electricity is gone, it will be it will suffer the setback of it. Okay. Now option A, that is wrong. Turning errors are decreased, or you can also say turning errors don't exist in remote sensing compass. So that is wrong. Detector unit is exposed to high deviation errors. Now the detector unit of a remote sensing compass is mounted on the wings of the plane for the main reason that at that location, on the wings of the plane, this compass will not be subject to the local magnetic influences of your aircraft. Okay, and that's how they achieve to eliminate deviation or to reduce deviation values as much as possible. Okay, so Alpha and Bravo are irrelevant. Charlie is the right answer. So what will be the effect on its on direct reading compass when aircraft on equator accelerates while traveling westwards? Now your aircraft is on the equator. That means it's neither in the north hemisphere nor south hemisphere. Okay, so it's perfectly on the equator, right between the north and south hemispheres. Okay, so this is your equator, north pole, south pole. It's flying westerly direction, and flying westerly it is accelerating itself. So what will happen? So indicates a decrease in heading, indicates increase in heading, no change. So correct answer is option alpha, no change. At magnetic equator, you will not have any acceleration, deceleration error, also turning error. Okay, so that is one advantage. But if you are flying in the north hemisphere, you will have turning errors, acceleration, deceleration error. Again, go in the south hemisphere, same two errors, right? But on equator, when you're flying at equator, whether you fly westerly heading or easterly heading, to accelerate your aircraft, you slow down your aircraft, doesn't matter. Accurate heading will be shown to you by your aircraft compass. Next, a ground feature appears 30 degree to the left of the center line of cathode ray tube of airborne weather radar. Cathode ray tube is the screen. Okay, so do watch my airborne weather radar lectures. There are many questions. I have covered many such questions over there. So cathode ray tube, Draw like this, draw one perpendicular line. This perpendicular line will be the heading of your aircraft, true heading. Okay, so your aircraft is on this at the center here, flying straight, flying its heading, and there is an object, a ground feature, an island, forest, whatever, 30 degree to the left of the center line. That means relative bearing of this particular ground feature is 30 degree to the left of your heading. Okay, so minus 30 degrees. So let's say that forest is somewhere here, 30 degree left hand side. So minus 30 degree. If the heading of aircraft is 355 magnetic, variation is 15 east. So magnetic variation true. So magnetism or magnetic heading 355, variation 15 east. Now when variation is east, magnetic is least. That means true direction will be more than magnetic. So true heading will be 010. The true bearing of aircraft from the feature. Okay, we have to find out true bearing of aircraft from the feature. That means true bearing of aircraft from the ground feature. So from something, that means we have to find out QTE. Okay, QTE. Magnetic bearing of aircraft from this feature will be QDR. Okay. True bearing of aircraft towards this feature will be QUJ. Magnetic bearing of this aircraft towards this feature will be QDM. Now QTE, right? So formula is Q QDM equals to magnetic bearing to the ground feature equals to magnetic heading plus relative bearing. So what is the magnetic heading of aircraft 355? Relative bearing is minus 30 degree because it is to your 30 degree left hand side. So 355 minus 30, 325. That is QDM. Magnetic bearing towards that ground feature. QUJ will be what? QUJ is nothing but true bearing towards that ground station. This is magnetic, this is true. So we want to convert magnetic direction into corresponding true direction. We will make use of variation which is 15 degree east, right? So variation east, magnetic is least. Magnetic is 325. So true will be more than magnetic because variation is east. So 325 plus 15 is 340. Now what will be QTE? QTE will be QUJ reciprocal of that. So 340 minus 180, that is 160. Option Charlie. Okay. So this concludes the lecture. I hope you have understood all the 10 questions I have answered and explained. If you have any questions, let me know in the comment box. And I encourage you all to practice these questions again and again without looking. All the best.